I'm changing the notes to do this example instead of the first one that's listed there because this will illustrate some ideas better. Here we have a power series and we're trying to find the interval of convergence. We found the limit as n goes to infinity of a sub n plus 1 over a sub n. This whole process is the first step of what's called the ratio test, when you look at the ratio of consecutive terms. As we go through all the algebra, we see we get this expression, which is not 0 and it's not infinity. So we're looking at the case where this is a finite value, which means that our radius is going to be finite and we'll only be able to go a certain distance from the center. To motivate the next step, I want to talk about what we did at the very beginning of the entire chapter, which was to look at geometric series with simple values. Things like 5, 1/2 to the nth power, or in general, n from 0 to infinity of some value to the nth power, which we said would equal 1 over 1 minus r, as long as this value was between -1 and 1. That was the idea. And if you go back to those first notes, it was because we had to have these numbers getting smaller and smaller and smaller. We want to force this limit to do the same thing. We want to force this to be between -1 and 1. And whatever x values we end up with are going to affect whether or not this is between -1 and 1. So the very last thing, once we do all this work and get down to like, hey, we're going to have this expression with x in it, we want to make sure this is between -1 and 1. This thing equals this. So we just need to find the x's that guarantee that 4x plus 1 is between -1 and 1. So the bottom line is, once you do this entire ratio and this limit and get this expression, if it's not 0, if it's not infinity, whatever expression you have, you need that expression to be between -1 and 1, and now we're going to use old school algebra to solve this thing. That's going to look like this. I want to subtract 1 from here, so from here and from here as well. Give me -2 less than 4x less than 0, and then divide everybody by 4. And what that's telling me is, as long as x is between these values, this entire limit's going to be between -1 and 1, and then, whoa, this thing's going to converge. So my interval of convergence is maybe, well, actually we can't talk strictly about intervals just yet, but I'll tell you something else. Based off of here, can you see that the center is what's right between this guy and this guy? The center is at x equals 1/4. That's exactly what would make this guy equal 0. That's not a coincidence, except for I'm going to say -1/4. Haha. And that means that the radius is going to be, well, if 1/4 is my center, and I can go as far, -1/4 is my center, and if I can go as far as 0 or -1/2, whatever this distance is, that's my radius. So my radius is going to be a half. No, it's not. It's a fourth. It's a fourth. Now, the reason why I'm not actually talking about intervals just yet is there's going to be a whole other section dedicated to whether or not we include the -1/2 or the 0 in our final analysis. But for now, all you got to know is when you get this final expression, if it's not 0, if it's not infinity, you want to find the x's that force it to be between -1 and 1, and then from that you can figure out the radius.